Okay, welcome back. I'm sure you went for the break. All right, so we're talking about creating composites for our constructs. So, with the example we've been working with from for this particular session, we've been looking at the constructs: green entrepreneurial orientation, strategy performance, operational performance, market dynamism, and then market performance. They are multi indicator constructs, so we need to compute a single indicant variable for them. So we can use regression. If we're doing structural equation modeling, we don't need to average them. But for OLS, we need to compute their averages. And I was explaining to you that anytime with SPSS, anytime you want to do anything about the data set itself, like split the data or select certain cases in the data, you just come to the data menu and the tools are there. But anything that has to do with manipulating the variables in the SPSS, you come to transform. And when it comes to performing any form of analysis, you use analyze. Okay, so we want to manipulate a data, so a variable, so we come to transform, and the first option is compute variable. I believe some of these basic steps are in the slides we shared with you, session 5. Okay, so when you click on compute, SPSS will give you this window where it asks you to name your target variable. You name your target variable. So we want to compute a composite variable for green entrepreneurial orientation. So how to hold the mic and type. So let me just put this. Let me see. Okay, there's no other variable with that name. Green ends. Now you see an equal sign here on the right hand side. That's where you enter the expression. So any mathematical expression you put there will work. Now what is the formula for average? The summation of the various inputs divided by the number of inputs you have. So you do not type with your hand. When it comes to the variable names, don't ever type with your hand. You have to pick it from the left here. If not, it will not work. Even though you can simply type GEO1 here, do not type. So, you know, in stats, average is the same as mean, right? Please, I need feedback. Average is the same as mean. So we will just do an example with the simple average formula where we sum the constituents in the parentheses divided by the number of the indicators. So we have GEO1 plus GEO2, GEO3 all the way to 5, and since we have 5 of them here in the parentheses, we divide by 5. The simple arithmetic way of computing average. So make sure you type a name for the target variable, then you enter the appropriate expression here. So you open a parenthesis and you select the items from the left panel. Okay, once you are done, you click on OK, and SPSS will record a new variable created at the bottom of your variable view, the last one. We only had up to 41, but when we created grant, it also came, and then we have 2 variables here, an additional variable. So you can give it a label. All right. So let's go ahead and create for operational performance, which is from SPP1 to 6. From here, the last function you use is record. So we pick and say operational performance. So since let's use the an alternative formula instead of using the simple average formula, we can use mean. We can ask SPSS to compute the mean of whatever you put in parentheses. So this is the second approach. But what? You don't have this? You have it. I'll share with you. Okay. So remind me when we are done so I can share the data with you and you can practice. With the mean approach, when you are using the mean formula, you separate each of the indicators or variables with a comma. So we pick SPP1, comma, and then SPP2, SPP3, and then comma. You have to make sure that you only include indicators that passed the CFA. So if for let's go back to our CFA and see if so for SPP 1, 2, 3, 4, 5, we removed SPP 4. So what it means is that for the computation we are doing here, we cannot include SPP 4. I hope you are with me, because SPP 4 did not pass validity, so we dropped it along the line. So you make sure over here you only include measures or items that passed the measurement validation stage. So because of that, we drop SPP4 from the composite variable computation. So for the mean approach, you type mean, then you open parentheses and you bring all the indicators you want to compute their mean for, separated by a comma, and then you click on OK, and operational performance has been added to your data, your variable list. We will do the same for market dynamism and then market performance. So market dynamism. I just remove what is in parentheses here and then replace them with the indicators for market dynamism. MD1, comma, MD2, MD3, and then MD4. Once I'm done, click OK. That has been created. And our last variable is market performance. So I'll replace what is in the parentheses with indicators for market performance. To SMP1, SMP2, SMP3, and then SMP4. That is it. So essentially, these are the variables we are going to work with in our regression model. We have to go through the ordeal to make sure that our data satisfies reliability and validity conditions. Now we are going to perform our regression, and because of the fact that we use multiple indicators to capture each of the constructs, we need to average them for each construct, which we have done now. Okay, so we can go ahead to specify our regression model. So let me put a sample model here that we will try to run. So this is a very simple research model. We are trying to predict market performance by green entrepreneur orientation and market dynamism. This is just direct relationships we are trying to, very simple, okay? All right, so we come back to SPSS, we go to analyze, we go to regression, and under that we select linear. So in this window, you need to specify what your dependent variable is. So you scroll down, we see market performance here, so we can slot it there. Then it asks you for your independent variables. Let's include some control variables: firm size, firm age, and then these two dummy variables specifying the industry or the nature of the business. So we can do this. And our key predictors are green entrepreneur orientation and market dynamism, so we can add them here. So this is a simple regression we are doing, but it's called multiple regression because it has multiple predictors here, your control variables and your main predictors, green entrepreneur orientation and then market dynamism. Then we click on OK. Once you specified what you need to, click on OK. The first example is just a basic one, so I don't want us to have unnecessary output there. So let me clear all the output I have so that we just have some decent output there. Okay, so this is the output you get from a regression analysis. It first gives you a summary of the variables that were used in the analysis, and then it gives you a model summary. In SEM, you're talking about model fit indices, but in regression, you'll be looking at model summary and ANOVA. So the model summary tells you the coefficient of determination, the R square of your model. The model that you have specified, all the variables you have indicated, you are using them to predict your outcome variable, which is market performance. To what extent are they able, or how much variance in market performance is explained by those indicators or those predictive variables or predicting variables. That is what is recorded here. So you are given an R, then when you square the R, you get the R square, and you're also giving the adjusted R square for model parsimony. So from this model summary, what is our R square? 0.177. So normally when you are interpreting this is given to you in decimal, so you can convert it to percentage, 17.7%. So what this is saying is that this model we have specified, the data is telling us that GEO together with market dynamism are able to account for 17.7% of market performance, of changes that can occur in market performance, variations that can occur in market performance. Only 17.7% is accounted for by these two factors. And my question is that significant? Is it important enough? Is that adequate? Is it adequate that our model is able to account for 17.7% of our outcome variable? Is it adequate? Oh, I need some response. It is quite debatable, but I don't get your opinion. It is adequate that we run a model that the coefficient of determination, your R square, is like 17.7.
The person of this is come up. You'll be challenged that your house is too small, and you have to defend it. So I'm asking, does the size of the house matter? To what extent? And how do you determine if it's adequate? Regardless of how small it is or how big it is. These are so many factors that can account for market performance, right? You have singled out only market dynamism and green entrepreneurial orientation. So it can only explain a portion, a percentage of the changes in market dynamism, market performance. So it is not adequate to just look at the absolute value of the coefficient of distribution to say that the model is good enough or not. When you are dealing with econometric data, the accounts guys, the finance guys, their predictor variables are usually or the outcome variables are usually either a product or the transformation of the predictor variables. They are so related. They are so directly related that the outskirts are always large or huge. But when it comes to the start to and I steady, sometimes the distance is very wide. The distance or the gap between or the relationship between the factors we study as independent variables tend to be very far away from the predictor variable. If you look at factors that affect your market performance, can you tell me variables that are more direct to market performance? Think about it like your market share, your sales, your customer base. That's what you're looking at as market performance. Okay. What are some of the things that are directly or can directly inform your market performance? Promotion, discount sales, aggressive marketing, those kind of things, they are so direct. So if we were to bring all those factors here, you see that that's where we shoot up for our model. But those are obvious. Every business knows that you must do advertisement, you must do promotion, you want to. But so those are threshold factors. That's why you might not say them because every business knows that you must advertise. Every business knows that you must do this promotion, you use this promotion strategy to increase your market performance. You must manage your customer relationship together. So beyond those threshold factors, you are going to look at things that don't seem like but plays a crucial role, a differentiating role when everybody is doing advertisement. So you realize when it comes to business and social science, those are the unicorns we are looking out for. They are the differentiators. They are what differentiates a performing firm to the failing one because as for so everybody does it. So we are looking at how you being oriented can set you apart and give you a unique, not so obvious advantage to the ordinary mind, to the simple mind. So it is common that in our kind of studies, you will find an R square that is not too enthusiastic. So R square that is hanging there a little. But let me ask you, if every month your bank, you decide to deduct 5% from somebody in this last salary every month, you consistently deduct 5% from their salary. Do you think they take it lightly? How will you feel? You will say that depends on your salary, right? But every month, for no reason, the bank deducts 5% from your salary, would you say that 5% is small? Like you could have paid a lot of people.
So that's the difference when it comes to the business researchers and social sciences, because we are looking for that unseemly thing that creates a difference. So it's likely you are not going to get that fat R square. So what matters to us is that R square is not just, it didn't just occur by chance. It's not just some white noise, but it is actually significant. So that's where we, after looking at the R square, the question is it significant? Does it reach statistical significance? Then you come to the ANOVA table and you are interested in the the Fisher score here. The rule of thumb is as long as the Fisher score is greater or is at least 2, it is good. But we don't have to use the rule of thumb because the significance is also computed for us. So you evaluate the significance of the F statistic. If the significance is less than 0.05, then we conclude that our model is what? Significant. And that this 17.7% variation in market performance accounted for by our simple model, we can have confidence in it. It means if you convert this to 100%, if you multiply this by 100, you get 0.1, right? And if you deduct 0.1 from 100, you get what? 99.9. So we can be 99.9 sure that this model we have specified account for roughly 17% of our market performance. So to a manager, if you are able to but before, the variables we are actually interested in, which are our key predictors, we have a lot of control variables in there. So we now need to go to the next table, which is the coefficient table, to determine, we have a lot of factors here, which of them are really accounting for this 17% variation in market performance. Constant, things we have not considered. Even if these do not change or do not add, something else is accounting for market performance, which we have not considered in our study. So those ones are usually huge. So in a model where you include all or almost all of the important factors that account for your outcome variable, you see that the constant will be decreasing. It will diminish, right? Firm size. The estimated parameter is 0.158. A standard error is 0.106. And when you divide the beta by a standard error, you get the T. And from the reading here, the T for firm size is not significant. Firm age is negative, but not significant. Food, that is firms operating in the food sector, the estimate is positive and T value suggests that it is not significant, so they don't contribute. Then how about building materials sector? That one too is positive but not significant. Then we have green entrepreneur orientation. It is positive and it is highly significant. The market dynamism, positive but it's not significant. So we are happy here because our key predictor, which is green entrepreneur orientation, has emerged to be the only significant factor accounting for or contributing to the 17% explanatory power we have here. So in your hypothesis evaluation, you are interested in the key predictor you hypothesize about, and you are to report the estimate here, that's the beta coefficient, and the t-value, and the level of significance. You would have to produce a table that looks like what we have here, but in a more formatted form. If you want to do all that, we might not finish, but if you don't mind, I'll just try to do a simple regression output table so that you know what you need to report in a regression output. Okay, it can get messy, but at least if I do the simple one for you, you can also look at previous studies, either previous thesis from the library or from KNUS's DSpace if the internet restores, or downloaded articles, and you look at how they present the results section, and you can learn how to present the regression output. It is so easy from SPSS output here because you just copy this table. This table has most of the information you will need, so you can just copy it. Let me take it to Excel. Okay, for now we have just a single model, so now I'll remove columns I don't need. I don't need a standardized estimates, so I can remove that. Okay, so pretty much this is the table. If it's just a simple study like we have just done, only one outcome variable, no other extra analysis around it. This is all the table you need to present, but then you need to give the details about the models and the overall model significance. So let me so what we normally do here is add a layer like a header within the table to report the model fit indices. So let me do that. So we are interested in R square. Then we have F's Fisher statistic. Our R square was 17.7%. I think we can even add another statistic here. Adjusted square. That was 13.6. 4.342. 1, 2, 3. Okay. All right. So once you add this information, your sample regression table is complete. So what is left is with just taking this office word and then adding all the embellishment to make the table look nicer as you would want it. So So let me take just a few minutes to design this a little. So when it comes to presenting tables in academia, we don't want plenty lines. So you remove all the borders just to tell us the end of the table and to separate the headers from the content of the table. So you would often see that most tables in academia, they are presented like this. Okay, it makes it easy to read from, and then okay, so with a simple study like this, it is easy to present most of the information here. But when you have a large study that have a lot of, you run multiples of the regression, then you have to begin to think about how to make this table simpler. So in most cases, what we do is you present the beta like this, I mean the coefficients, and you put the t value in parentheses, just as I demonstrated in to you in the CAP model. And instead of presenting another column for significance, we use the starring approach to represent this. So any significance that is less than 0.001 will take 3 stars. Any significance that is less than 0.01 will take 2 stars. And any significance level that is less than 0.05, just 0.05, will take 1 star. So in that case, you can just put the t values against the coefficients in parentheses, and then you attach a star to it if it is significant as 5%, 2 stars if it is significant at 1%, 3 stars if it is significant at 0.1%. Then you can scrape off all these 3 columns and you have only 1 column for this single regression you run. Now, with the model fit, we've explained that already. It tells us whether the entire model itself is significant or not. R-square is computed because it looks at how many other variables you included in your study, and then looks at their relevance in contributing to explaining your outcome variable, and it's based on that to penalize the initial R-square. So usually when you have plenty other variables that were not significant, your R-square will diminish more. So from 17, it has shrunk to 13. It is penalizing for the fact that you added plenty variables that did not contribute to explaining your outcome variable. So if you have a lot of that, in order for you to not over exaggerate, the explanatory power of your model, you go for the adjusted R-square. So it's a good practice that when you are reporting, you report the adjusted R-square so that the decision maker who is highly risk averse will make their judgment based on the adjusted R-square other than the actual R-square. Okay, in our case, only one of our predictors was significant. The constant is not passed. Only green entrepreneurial orientation was significant, and every other variable we included was not significant. Okay, they are here. So because of that, it becomes important to emphasize on the adjusted R-square other than using the main R-square. This is simple, or a simple multiple regression. Is that okay? Now let's complicate this a little bit. So we go to regression again. I just want to show you some of the other features in regression. Then we can move on to do something more interesting. These are our two key predictors. The rest are covariates or control variables. The question we want to ask ourselves is, assuming even some of these control variables were significant in predicting market performance, one question we may want to ask ourselves is, how much contribution does the variables we are hypothesizing about contribute to the coefficient of determination? When that happens, what we do is we take them off. Look here. You enter the predictor variables or independent variables in blocks. So the first block will contain just the control variables. Then in the next block, you click on next. It gives you another empty space where you can now introduce your key predictors. This is what we call hierarchical regression. You enter your independent variables in blocks. Usually the first block will contain only the covariates, which are the control variables. They are the variables you are not making any hypothesis against in your study. Then you can begin to introduce the ones you are actually hypothesizing against in the subsequent blocks. Now when you do that, you need to tell SPSS to compute the R-square change for you and to test whether that change in R-square from moving from the effect of the control variables to your main predictors, whether these two alone contributes to R-square and how much do they contribute to that. So you come to statistics, and then you select R-square change. You make sure you check the option R-square change and then continue. When that happens, your model summary table was split into two. If your hierarchy was only two, if you had only two blocks, if you entered your independent variables in two blocks alone, or if it's three blocks, you are going to have three models. If it's two blocks, you are going to have two models. Because we entered only two blocks of predictors, we have two models. ANOVA, you're going to have two models, and coefficient table, you're going to have two models. Compare that to the initial one. Model 1, model 1, model 1. Then here we have model 1, 2, 1, 2, and then 1, 2. What SPSS does is it first enters the variables used in the first block, which is in our case just the control variables. Then in the second model, it will add the key predictors to the initial variables. But the difference is that it is able to determine the contribution of the second block of predictors, their contribution to the model's significance. So when you take the first model, it says R-square is 0.087. Converted to percentage wise, that will be 8.7 coefficient of dissemination, which means the control variables are able to explain only 8.7% of market performance. Now, if you go about asking, is that significant? The answer lies in evaluating the F change or the F statistic for the first model and its significance. The F statistic is more than 2, that is 2.934, and the significance is less than 0.05. So yes, you can also verify that from the ANOVA table, in the first model. Now, upon adding market dynamism and then green entrepreneurial orientation, how do these two additions contribute to the model? Overall, the second model gives us an R square of 17.7% here, which is the same as we got from the initial example we ran. Now, when you come to R squared change, if you come to R squared change, it tells us that the addition of the second block of predictors, market dynamism and entrepreneurial orientation, brings in an additional 0.090 contribution to the overall R squared. That is, if you convert to 100% percentage, that would be 9%. Whilst the control variables give us 8.7%, market dynamism and green entrepreneurial orientation adds an extra 9% explanation to market performance. So together we have 17.7%. And is that change significant enough? Yes, F change says 6.6, and the significance is way less than 0.05. It's less than 0.01. So which means the inclusion of our key prediction variables makes a significant contribution to our overall coefficient of determination. So when we come to the coefficient, it presents us in two hierarchies like that. The first block is just the estimates and the evaluation of their significance for just the control variables. Then the nested model, the second part, is where it adds our two variables together with the control variables. So if you observe carefully, model 2 is synonymous to, or it's just the same as the first example we ran. That is when you lump everything together and you run them. The difference with hierarchical regression is that you are able to tell how much contribution your key variables are bringing on board in terms of the model's explanatory power. Other than that, it is not different from the first example we ran. Any questions so far? Okay, so I have some other data sets that we can use to do something more interesting that I want us to go and explore. We will do about 2 examples, then I'll share those data with you and you can practice on your own. If you have questions, you can ask. Okay. All right.